Hi, let's look at this question. So this question is determine the minimum temperature at which reaction can be spontaneous, basically. So we need to use data booklet section 1, and we have been given Gibbs free energy delta G is equal to delta H minus T delta S. So delta H is change in enthalpy, T is temperature, delta S is change in entropy. So if we look in this question, so we have been given delta H naught, which is plus 4.2 kilojoule per mole, and we need to work out delta S because we have been given the standard entropy values but not the delta S. So we know delta S is equal to sum of the entropies of all the product minus sum of the entropies of all the reactants. So product is mercury 2 sulfide black, and its value is plus 8.3 minus, so reactant is mercury 2 sulfide red, and its value is given as 77.8 joule per Kelvin per mole. If I solve this, that will give me plus 10.5 joule per Kelvin per mole. Okay, one more thing I need to do is delta H is given in kilojoule per mole. Entropy is joule per Kelvin per mole, so we can convert that into kilojoule as well by dividing with 1000. So if I divide that with 1000, so I can convert that into kilojoule per Kelvin per mole, and that value will be now 0.0105. So let's substitute these values in this equation. We need to work out minimum temperature. So we know delta G need to be below 0 for a reaction to be spontaneous. So we're going to assume delta G will be equal to 0. So 0 will be equal to delta H minus T delta S. So let's rearrange for T. So T will be equal to delta H over delta S. And the value of delta H is plus 4.2 divided by value of delta S is 0.0105. So if I solve this, that will give me 400 Kelvin. So if we heat mercury to red, I think above 400 Kelvin, then this reaction will be spontaneous. So one key thing in this question is we need to make sure the units for delta H and delta S, they are consistent. So either you convert delta H into joules or you convert delta S into kilojoule. Thank you.